Morning, everyone. And first of all, thanks for the invitation to speak today. It's lots of fun to talk about lighting programs, particularly turkey lighting programs, because they're such cool critters. I enjoy working with them. Okay, and nothing. There we go. That's going to work. Thought I'd start a little bit about talking about some of the challenges of working with lighting programs. It's such an interesting area, and it has such an incredible influence on all kinds of species of animals, not just birds. But there are some significant challenges with working on this in terms of poultry production. The first one is that your facility really needs to be designed and built for lighting programs. And so the use of one room, for example, split by a curtain really doesn't work very well. There could be light leaking, but also sound back and forth. So typically what you need to have is a facility that has a research facility that has individual rooms or the ability to use replicated barns to do this. So that's a challenge. And again, it just makes it a little tougher to do if you don't have this. Second one is that some of the measures that we're going to measure today are really tough to do when you have small numbers of birds. And with the challenges that we have with animal care, for example, sorry guys, I haven't actually talked to anybody this morning yet. More and more pressure to reduce numbers, which makes sense, but then it makes real difficulty in trying to find significant differences for things like mortality, which tend to be relatively variable from room to room. So it makes it a little bit different. And so one of the reasons that we fall into doing some of the research on lighting programs, we do a lot of work on lighting programs. We've got turkeys in the barn again currently with some lighting work, is that our building was designed specifically for environmental work. There are 9 individual rooms in this facility, which are large enough to house relatively big numbers of birds. Excuse me. For example, we did some heavy tom work looking at stocking density. These numbers in the brackets are the numbers of birds we had in each room. So one replicate with, for example, 236 birds allows us to have a very big group of birds, and then we replicate that experiment twice, gives us large numbers and confidence in some of the data that tends to be quite variable. So today I want to tell you some of the work that we have done with lighting programs. And I have to say, Shauna mentioned the number of talks that I have done. I've done a lot. None are ever more contentious than the use of lighting programs, which I still have difficulty understanding. But this area is the only program where I did a producer talk and I had an audience break out in a fist fight. So that it's still contentious, and I still have questions about the use of lighting day length for both broilers and turkeys. So it's interesting. So let me talk about why we started to do the work with lighting programs in the first place. And before I started my PhD program, we talked to a lot of producers and asked what they were using in terms of lighting programs. And most of them used 23 or 24 hours for broilers and for turkeys. And when I talked to them about why, the theory made sense. It meant putting birds into an area where they had almost continuous access to light. It meant they could see where they were and they could go where they wanted to go, and they could feed when they wanted, and they could do this when they wanted. So some of the theory behind this really made sense. However, when we look back into turkey data, the work is pretty old, 30 to 40 years ago, before we started to see some of the work on lighting programs. So that really changed things. So what this meant is that in terms of turkeys, most of the decisions, and actually we see this in more than just lighting programs, many of the decisions on what we do with turkey management really comes from broiler research. Again, it's expensive and difficult to do turkey research. They do interesting things like chew ends off water lines, a number of other problems that we have. So many of the decisions in terms of management for turkeys were and still are in some cases made from broiler research. So Shauna also mentioned our initial research at University of Saskatchewan focused on the impact of day length, and that gave us the recommendations for Avigen that they use internationally currently. So I have to talk a little bit about broilers, because some of the things I'm going to show you about turkeys are going to show the differences. And it really highlights how it's important for us to base turkey management off of turkey research. So hopefully we can continue to find funding in turkey research to show this. But in the broiler work, just a very quick summary about what we found there was that use of 23 hours of light, that initial theory of why this is a great thing to do, did some crazy things. It actually reduced growth early on, it increased growth early on, which causes some problems with health. But overall, by the time birds went to market, they were smaller when we gave them access to 23 hours of light. So really different than what the philosophy was for why we would use that. We saw higher levels of mortality and culling, particularly from metabolic and skeletal disorders. We saw lower comfort, nutritive mobility behaviors in birds when they had long day lengths, increased activity, which affected bone quality and litter quality, lack of diurnal rhythms, and that affects growth hormones, immune function hormones, ocular growth, so many other factors. And so really, it's certainly demonstrated that the use of 23 hours of light was not recommended to raise broilers. And again, that's in the Avigen recommendations, that's in our Canadian Codes of Practice and many other places, and suggested that the use of something between 17 and 20 hours of light gave better production and welfare. So after we finished that data, well, we thought, we should look at this on turkeys. And our expectation was that we were going to see exactly the same data. Remember, we're basing so many decisions off broiler research. We're going to see the same data, only the differences are going to be bigger. And so we started the work on turkeys. Again, first work in 30 to 40 years when we started this work. Okay, so when we did turkeys, we used the same lighting programs that we did for broilers, and those were graded levels of day length: 14 hours of light, 10 of dark, 17 light, 7 dark, 20 light and 4 dark, 23 light and 1 dark. And in all cases, that dark was given in one in one section. Excuse me. This allows us to look at the development of regressions and how the data is performed. It allows us to see where the benefits really are. And then we do what we do with most of our research here. We focused on both productivity and bird welfare. So we can answer questions for producer groups. We can answer questions in terms of bird welfare. We can answer questions in terms of veterinarians and health maintenance. So it gives us a really broad picture. It's a big project, but it gave us some really good things to look at. Okay, so our experimental design, as I mentioned, whenever we do work in those rooms, we used 8 rooms in this case, but we repeat that experiment again. So it really gives us 16 rooms of data. In this case, we used Nicholas turkeys, we used toms and hens, and I've already mentioned the lighting programs for you. We measured data at a number of different points. I certainly don't have time to go through all of them today, but you can look at the papers. All of these data are published and gives you much more data than I have time to give you today. But in terms of body weight and feed consumption, feed efficiency, and mortality for production data, again, there's more. But for welfare data, we included all of those factors, plus things like mobility and breast blisters and ocular health and behavior. So it's cold enough in Saskatchewan this morning that my heater is coming on. I hope you can still hear me over this heater, but it is what it is. We're gonna go. Okay, let's look at the productivity data for these turkeys. We measured this is body weight. We measured this in kilograms at 42 days of age. I've put some pounds in just so you can see this data. So this is relatively young. Lighting programs are along the bottom, or the bottom axis here, and then the weight in kilograms along the left-hand side. This is early data, and we see exactly the same response that we see in broilers. And that is that early on, we see heavier weight when we put birds under long day lengths. So 23 hours had the heaviest weight. But remember, that's interesting because it means we're putting heavy weight on the birds early. It affects their skeletal system. It affects their metabolic system. So this is not necessarily a good thing in terms of welfare later on down the road. Adding darkness slows initial growth when we see this in turkeys. If we look at the data at 84 days, so now later on, and in this case, I split out males and females. Again, the weights are along the y-axis, lighting programs on the bottom, and pounds in some of the points on the right-hand side in red. Already we're seeing a difference. So here, at 23 hours of light, particularly for the fast-growing males, we see that they're lighter. So again, that original philosophy of constant light under 23 hours is already showing that doesn't make sense in terms of body weight. And that gives us some suggestions for some of the other factors that we'll look at down the road. When we look at the data at 126 days, Now we're even seeing that in the females. So adding darkness is actually increasing body weight at this weight, and we have actually the highest weight under 14 hours of light. That 10 hours of darkness here is given in one section. Light intensity for our dark period in this case is 0 lux. It's black. So we're seeing effect, and longer exposure to darkness increases body weight even more. These are feed efficiency data shown in this slide, mortality corrected. On the left-hand graph, we see the gain to feed ratios from 10 to 105 days. And here's where we start to see some split for the from the broilers. In broilers, regardless of the age, when we added darkness, we saw improvements in feed efficiency. And one of my master students went on to show this is because they hold feed in the gut for a longer period of time during that dark exposure, giving it a longer period to adjust. But we're not seeing that same thing in turkeys. The earlier data had some suggestion that possibly the long day lengths have poor feed efficiency. But if we look at the data over here on the right-hand side, 10 to 126, so after the whole flock, we actually saw improvements in feed efficiency under 23 hours of light. We don't understand that. We don't have a reason for that, but it varies significantly from what we see in broilers. So again, looking at broiler research and saying this is what's going to happen in turkeys can be a surprise for you. So in this case, it is different than broiler data. We look at health data. This is mortality. So again, large numbers of birds give us pretty confident data in this. This is placenta placed along the y-axis and the lighting programs along the bottom. And in this case, we see higher mortality under 23 hours of light. So this part is the same as what we would see with broilers. However, what's really interesting for turkeys is between 14 and 20 hours of light, we saw no benefit. But those long day lengths did increase mortality in this large scale trial. It also caused some other issues, and this increased the number of cull birds that we saw. These are pendulous crops, and in this case, we saw absolutely more in the females, in the green bars, under, doesn't matter which lighting program, other than the 14 hours, more in the females. But as we go to 23 hours of light, we saw higher levels of pendulous crop, particularly in the females. These are breast buttons. Again, we saw a linear relationship here with higher levels under 23 hours of light. And this makes a little bit of sense when we start to look at some of the behavior data. These birds just were much less active. And so they spent more time in direct contact with the litter, which increases breast buttons. So let's move on to some of the welfare data. And when we look at excuse me, when we look at welfare, there's a number of parameters that we look at, same as many other research programs. I have growth in here and I have mortality values because particularly growth is a little bit unusual, but it gives us a good hint. And do we see a relationship when we look at all of these? We absolutely do. So coming back to the growth, why do I say that gives us a hint, just a hint? Remember that we talked about 23 hours of light in the theory of this being fabulous, but it's not. And anytime we think that something is going to be very strong and we see a definitely different relationship, it just gives us a hint that something is not correct. And we see that in here. So the growth rate here, as in broilers, gives us a hint that those long day lengths are going to reduce bird welfare. The health data is a no-brainer. We see that higher mortality under 23 hours of light. Breast buttons is a no-brainer. We see that as well, and these often lead to culling for these birds. But we measured so many other factors. So we looked at mortality overall, we looked at causes mortality, but this is gait scores in the flock. Again, lighting programs are along the bottom, and this is the average score for you just here. And again, so much more of this data is in this paper if you take a look. Males are in the blue bar, females are in the green bar. We see, again, higher levels of immobility or poor mobility in males than we do females. But in both cases, it's a linear relationship. And we see mobility going down for those birds when they're under long day lengths. And this is very similar to what we would see in broilers. We look at behavior. It gives us some of the suggestions for why we saw more breast blisters, potentially why we see more mobility issues as well. So this is resting behavior. We're doing 10-minute scans on these videos over a 24-hour period. So that's important to remember because birds, for example, under 23 hours, only 1 hour of that is dark. 14 hours, 10 hours is dark. And we continue to do the data over those dark periods. So let's look at the graph on the left-hand side. This is the percent of birds that were found to be inactive, just laying on the litter, doing no other behavior. And you see again, which differs from the broilers, that birds under 14, 17, and 20 are pretty equal. It's really interesting how they're different than the broilers. But birds under 23 hours of light, that jumps up. And so those birds are spending so much more time just laying on the litter, not doing any other behavior. That affects litter quality because we don't see them turning over litter as much. It affects breast buttons because there's more contact time and could, if it's higher litter moisture, could lead to more foot pad lesions, which can affect mobility. So that's interesting. When we look at the data under 17 hours, we still see that spike under 23 hours of light. So they continue to be less active. This is walking behavior. Again, theory, 23 hours of light gives them more time to move and walk. We see at 11 weeks, that's not the case. And birds under 23 hours of light just aren't walking as much. That makes sense because we just saw that they're laying on the litter that much more. If we look at the data at 17 weeks of age, again, interesting, more walking at 17. By this time, we didn't find any differences between the birds on 17, 20, or 23 hours of light. Environmental pecking. So again, moving around, usually scratching comes with this as well, affects litter quality because as birds don't do this as much, they do not turn over the litter. It doesn't have the same opportunity to dry. Both at 11 weeks and 17 weeks of age, we see that birds under 23 hours of light were doing less of this. And again, they're spending more of their time just laying inactive on the litter. Coming to diurnal rhythms, because this is a really part that's interesting in terms of turkeys. And again, there's so much more behavior data in the papers. Please take a look at them if you're interested. If you're interested in diurnal rhythms or circadian rhythms, what that is a rhythm within the body that occurs about every 24 hours. So you tend to eat supper at the same time every day. You tend to have a bowel movement at the same time every day. Those are considered diurnal rhythms, and diurnal rhythms are important for so many factors. What signals these? The primary signal for these are changes in daylight. So night to day is the primary Zeitgeber for this. If that doesn't happen, what happens is that the body runs on what's called a free running rhythm. In other words, it's not 24 hours. It could be 26, it could be 18, it could be a number of different things, whatever it is. So function of rhythms helps a flock to do a number of things. It coordinates behavior and physiology within the body. It also coordinates when activities occur within a group. And that's really important because if we think about the importance of sleep for birds, and we'll come back to this, when birds are on free running rhythms, some birds are attempting to sleep while other birds are not, and they're on a different rhythm and they may be feeding. And so we get disruptions occurring with the birds that are trying to sleep. We showed that this can occur in the broiler flock, in the broiler data. So this is broiler data, and we were able to do more work with the broilers than we could with the turkeys, where we actually went into the flock and measured melatonin levels, which are associated with darkness. They increase during the dark period, measured melatonin at various periods throughout a 24-hour period. And what we showed in that work was that birds given 14, 17, or 20 hours of light develop that nice rhythm. And I'm showing you on the bottom some of that. This is 14 hours of light on the left-hand side. The 24-hour clock is on the bottom axis. This is the level of melatonin in picograms per mil on the y-axis. The red dots are where we measured this, and the grayed out areas are the night periods. Look at this beautiful rhythm. It's low in the day. It comes up in the night period exactly where it's supposed to in this flock and starts to come down when the birds anticipate that morning is coming. So this is what we would like to see. What's important here is the difference between low and high, that level, and the length of time that the level of melatonin stays high during the dark period. So that's what makes this important. Nice, beautiful rhythm under 14. We found a good strong rhythm under 17 hours of light, a weak rhythm, but a rhythm under 20, and absolutely nothing under 23 hours of light. So if you look at the right-hand graph, this is 23 hours. It's all over the place. And in fact, we found the highest levels of melatonin outside of the dark period in here. So this flock is on a free running rhythm in terms of melatonin. With turkeys, it was really tough and expensive to euthanize that number of birds, but we did some other measures as well. So we looked at turkey eye weight. Eyes grow in a diurnal pattern. Of all the weird things you're going to learn today, eyes grow in the diurnal pattern. They grow more in the light period than they do in the dark period. And it's one of the reasons that people who live in areas of the world under 24 hours of light struggle with some of their ocular diseases, is partially to explain that. So when we put birds under 23 hours of light, we saw in the broilers that their eyes continue to grow. And that's interesting because it changes the shape of the eye. The socket itself doesn't change. So the eye gets bigger. It's got to go somewhere, and it changes that shape with here. So we wanted to look at this with turkeys as well. And we did that. You can see we have similar data for birds under 14, 17, and 20 hours of light, but then we have a big jump for the turkeys exposed to 23 hours of light, significantly higher. And it suggests that, again, we don't have a nice diurnal rhythm occurring in these birds. We also looked at the dimensions. These are corneal diameters, the anterior, posterior. So looking from front to back and top to bottom, those kinds of things. And we see a difference in the shape. So in all cases, the 23-hour birds were the most extreme, sometimes so much so that it was really interesting. So again, we're seeing bigger, heavier eyes. They got to go somewhere, and the socket's not going to change. So it changes that eye shape. These are dorsal-ventral, medial-lateral, all of the diameters. Everything we looked at tells us that that changes shape. So it's interesting. We also were able to work with some ophthalmologists from our Western College of Veterinary Medicine. They brought all their equipment. We even convinced some human ophthalmologists to come out and look at our birds, and we found something really interesting. This is an eye of a turkey exposed to 23 hours of light near the end of their production cycle, so 15 weeks of age. And what the ophthalmologist found, if you can see in the center of this screen, I tried to circle it with the white circle, that small white dot, that's a cataract. And every turkey that we looked at exposed to 23 hours of light had some level of cataract developing in their eyes. So that changing in shape resulted in some significant issues with eye health. And in some cases, some of these birds were determined to be blind. So it has a major impact on bird health in terms of ocular development. We also wanted to look at diurnal behaviors. And again, we did this with the broilers. So we took the behavior that I showed you averages before and looked at how it develops over the 24-hour period. So the graphs on your screen here are on the top left, 14 hours of light, below that 17, top right 20, and below that 23. And we've just scored the behavioral expression over every measure that we took. Again, the grayed out boxes are the night periods, and these are percentages of the birds that we found here. So what we want to find is that when lights go off, just before that, we should have a feeding behavior. And that's so important because it keeps feed in the gut throughout the dark period. So this bump that you see on the top left is very important. Then when lights come on, we expect to see an increase in feeding activity occur right after that, and then it slows during the day. So that's the nice diurnal rhythm that we should see and expect to see with feeding in a flock. Under 17 hours, we still get a rhythm, but it's a little bit weaker. Under 20, we get some strange things happening, some peaks related here. But under 23, obviously, we have a free-running flock and we have no rhythm designed at all. So again, it gives us a strong suggestion that we do not have diurnal rhythms forming in these flocks. And remember, that can affect growth hormone, immune function hormone, number of other parameters. So in the turkeys, we see strong rhythms under 14 and 17 for both behavior and eye size, eye health, weaker rhythms under 20 and nothing in 23. So that's really interesting. And again, gives us another suggestion that 23 hours of light is a significant negative effect for bird health in terms of welfare. This leads back to sleep deprivation again. Are we getting that sleep fragmentation where birds under 23 hours of light are trying to sleep and we see disruptions of that occurring? Our data suggests that absolutely that is. And sleep itself, when we don't get proper sleep, you know, and I know that for humans, it causes significant health issues. We believe that it does the same for birds as well. So big experiment, lots of data, and I've given you just a tiny little bit of it. But what did we learn from this? We learned that When we use 23 hours of light, we get a decline in market body weight and we get higher mortality. So for growers, using this is a problem in terms of economics because they're not shipping as many birds, and the birds that they are shipping tend to be smaller. In terms of welfare, this is a no-brainer. Poor mobility, more breast blisters at some of the ages, particularly the young ones, abnormal growth of the eyes, cataracts in birds under 23 hours of light at older ages. Behavior changes, we get inactivity, we get reduced exercise, reduced exploratory behaviors, and loss of behavioral diurnal rhythms. So some major negative effects of using 23 hours of lights for turkeys. So that's what that says. Don't do that. We strongly believe that some darkness is necessary to promote turkey welfare and improve productivity of broilers, and a minimum of 4 hours of consecutive darkness should be required for turkeys, in our opinion, based on this data. But there are some tricks, and I wanted to take just a few more minutes to go over how to use these. And there are significant concerns in some cases for using darkness in turkey programs and broilers, but there are some things that you can do to make this work easier. You can suggest the use of dawn to dusk, and every talk I do, I think this is so important that people use. So if you're not familiar with the terms, all it means is that instead of the lights coming immediately on in the morning and going immediately off in the evening, a timer be used that lets the lights come on gradually. So 15, 20 minutes, 30 minutes. I don't know if we have an answer to how long that should be, but it's a gradual change. And the same thing happens then at nighttime. And this is so interesting. If you ever get the chance to sit in a flock where we have immediate on and off, and then sit in a flock where they have these dawn to dusk, the behavior is completely different. So instead of loud vocalizations and everybody's up and running to the feeder, when we have an immediate change, it's a much gradual change. You get some birds get up and stretch, move to the feeders. Same thing happens at night. So we don't get the pressure on the feeders. Likely it could reduce scratching at the feeders, particularly in that morning period. So it's a simple thing if you've got a lighting controller box. If you don't have a lighting controller box, it also works if you have banks of light in a farm, or a farm has banks of light, turn them off, one now, one in 5 minutes, one in 5 minutes. So simple little tricks that might help with that. When you're making changes, if you're starting turkeys or broilers at 23 hours for the first few days, which many people are still doing, and you're going to go down to 20 hours or 18 wherever you go, make those changes gradually. So for us, we change an hour a day, no more than an hour a day. We change light intensity gradually as well. And we don't get the same disruptions to feed intake or feed efficiency when we do that gradually. Less stress on the birds makes for a better life for them. We strongly suggest that regardless of the darkness period, that it be given in one period. And we've got data in broilers to show that when we split this up, we have higher mortality overall. It disrupts the sleep. And if we watch the behavior with birds under fragmented dark periods, we see the first one, they go to sleep, then they wake up and feed. Second darkness period, they don't sleep as well. And if we get into a third one, they're really moving about significantly. So giving it in one period allows them that one good sleep. Dark doesn't need to be blackout if the daylight is bright enough. And Richard, this goes back to the data that you did at the same time we were doing some of this data. If the daytime is bright enough, the nighttime can be a little bit brighter, as long as they're able to differentiate day from night. So this is a really important point, particularly for turkey producers who are concerned about using a blackout night. Light color, so much interest in light color right now. From the data that we have, we don't know that it's as important as day length in terms of growth, in terms of health for birds. And I put this in here, watch the flicker with LED lights. You may notice that we've had 2 papers published in the last month looking at turkeys under light flicker, and it was not as detrimental as we thought it would be, but it's still a concern because people don't want to be in there. So your people that are working on farms may not be as interested in actually being in the barns. So that ends my talk, and I've left time for questions, if that's okay. Acknowledgements, Cherson Hatchery in Manitoba, Canada is amazing to us, and we would be in trouble without them. Avian Turkeys, Lilydale, CPRC, and the people who do all our work at the University of Saskatchewan. So that's it for my presentation.